There are many professional skills out there, communication, teamwork, but I feel like one of the most important professional skills is problem solving, because if you can solve problems, you can address all those other skills and improve upon them. One of the earliest books on problem solving was How to Solve It by George Polya. He came up with 4 different steps to the problem solving process: understanding the problem, devising a plan, carrying out the plan, and looking back. Now, if you go through the literature, you'll see that there's some problem solving philosophies that have 7, 8, 9 steps to them. This is nice and simple, 4 steps if it's something you prefer. One of the most important things to note is that students, when they get impulsive, or if they're just novices and don't have a good expert or foundation or framework for the problem that they're trying to solve, is they'll simply just carry out the plan and they ignore 3 of the other steps: understanding the problem, devising a plan, and looking back. And I think as we try to improve problem solving in our student skills, those are the 3 areas we often want to focus on, because students like to just dig in straight away. So with these 4 steps in Polya's model, my question to you, and please feel free to comment below, is what steps do you teach when you teach problem solving to students? And I'm going to go through some examples in different subject areas of how it might be approached. And of course, you have your own models. If you have links to some things, please share those in the comments as well, so we can take a look at some of those different models. Now, as we look at things and we compare this to, say, the scientific method, because there is no one scientific method. Some of the steps in the scientific method are observe or question, research, hypothesize, and those are all part of the first 2 steps: understanding the problem and devising a plan, then doing the experiment, and then as you look back, you analyze the data, you conclude, and you can see that those 4 steps from Polya are inherent in the scientific method. At Ohio State, we like to use Dr. Pi in our first-year engineering because it's a nice new mnemonic device and it's easy for students to remember. You can see that understanding the problem correlates with define and represent, and then you have plan, implement, and evaluate, which are very similar to the 2nd, 3rd, and 4th step of Polya's model. If you were to look at writing or technical communication, and we even tie this into technical communication at Ohio State, we have define, represent, plan, implement, and evaluate. And those correlate to identify the requirements and resources. And those requirements might be: who is our audience? What is the purpose? What are we trying to do? That's all part of defining what you're writing. Organizing the ideas and content, which is part of your coming up with a plan, making an outline. And then we have draft, which is really your implement, and then the review, revise, and proofing stage, which tie into your evaluate. If you look at a thesis or science fair project or paper sections, you often have introduction, literature review, methodology, results, conclusions, and recommendations. Once again, introduction and literature review, understanding the problem, methodology, devising a plan, results, carrying out the plan, conclusions and recommendations are like looking back. If you look at a marketing process, even if you're in business, you often do situational analysis and identify the opportunity, which is your background work, implementing, actually carrying out the plan, and then evaluating your performance. These 4 steps from Polya's model keep recurring over and over again, no matter what you start looking at. If you were to look at a history class and you're thinking of a problem, you want to locate and research primary and secondary sources, and then come up with your plan, go ahead and analyze it and interpret it, and then draw conclusions looking back. If you look at metacognition, some of the things as part of the study cycle are preview, attend, review, study, and assess. Your attend is carrying out the plan, and then you go and you review and you study and you come up with another plan, and it's almost has that iterative nature of the problem solving process built in. Because one thing to keep in mind is that while there's 4 steps, the looking back can often go back to re-understanding the problem better, or devising the plan better, or carrying out the plan better. So to oversimplify things, every one of these models has 3 things in them: prepping for the problem, solving for the problem, and reflecting for the problem. Now, why do we use so many different terms and models? Because everybody's trying to adapt it for what they do best. However, I would suggest that if you're in high school or middle school, you coordinate people across your grade level and decide what terminology do we want to use for problem solving. You coordinate with people vertically in your subject matter area and say, what model do we want to use for problem solving? And you're just consistent across the building. I think if you can be consistent and students are seeing those same terms in every grade, in every class, then they'll become much better and much more fluent problem solvers as things go on, and then you can get to the more detailed part of it later. Even if you decide to say, we're going to go with Polya's model in math class, but I'm still going to refer to it as prep, solve, and reflect. And when we talk about problem solving and we get into that prep part, I'm going to go back and say, our prep in math class is understanding the problem and devising a plan. Just like somebody might say, our prep process in writing and communication is identifying the requirements and resources, noting our audience and purpose and context, and coming up with an outline. I think you'd be much better off sharing that common language, and then as the students start to master it, breaking down into those more subject-specific areas, ways to define things. So in summary, as we're looking at kind of these three general ideas, prep, solving, and reflecting, which model that we went through before do you think works best for the subject you teach? Which do you think you'd get buy-in from people in your subject area or on your grade level? Even if you have a chance to have some team meetings, can you talk about problem solving and let us know what you decided and what you came up with? I'd really be curious to see what people decide to go with for different buildings, but I do think it's important, once again, that you come up with a common language so that students can see those connections between class and realize that problem solving in science, problem solving in math, problem solving in social studies, problem solving in language arts, problem solving in art. How do you decide what you're going to draw? Problem solving in music. How do you come up with a practice routine? That all of these can be related and that subject areas aren't just as distinct, because when we go to solve multidisciplinary problems and students go to solve those, them realizing that they use similar problem solving techniques in all subject areas will help them solve multidisciplinary problems much better. So I really look forward to any dialogue, any suggestions, any thoughts you have about how you teach problem solving, to put those in the comments, and we will see you next week where we'll have a special guest, and I'm looking very forward to that one.